All right, well, good afternoon, everyone. It's 2 o'clock. Welcome to the next edition of the NCSPA Real Deal on Steel webinar series. Thank you all for attending this now fifth session of our 7-part series. I'm Mike McGough, Executive Director with the National Corrugated Steel Pipe Association, NCSPA. And as usual, I will be your moderator for this webinar this afternoon. Today's topic, we'll be talking about the environmental benefits of corrugated steel pipe and the overall sustainability of the product. These webinars are being presented by the National Corrugated Steel Pipe Association in partnership with the American Galvanizers Association. As I said before, this is the 5th installment of this webinar series. It's hard to believe we're this far along and that there are only 2 scheduled for future, but we are continuing to host these every 2 weeks at the same time of 2 p.m. on Thursday afternoons, with the remaining topics covering quality and certification and rehabilitation. I take the opportunity to give you guys a quick reminder that PDH and learning units are available for those participating this afternoon, so please be sure to complete your information and take advantage of this free opportunity. Membership of the NCSPA is comprised primarily of steel coil manufacturers, coaters, and fabricators. The mills or manufacturers will produce and coat the steel sheet coil and then ship it to the various fabricating companies that will in turn roll form, rivet, or fabricate the steel into the various profiles for either pipe arches, or structural plate buried bridges that have been installed under our nation's highway system for over a century. As a quick review, on our first webinar, we discussed the types of coatings available for corrugated steel pipe. These coatings include galvanized or zinc-coated CSP, aluminized type 2 coated CSP, polymer laminated, and post-pipe fabrication applied coatings and paving such as asphalt, coated, and concrete lined. In reviewing each of these coatings, we covered the material specifications that have been developed, the decades of research that have been conducted, and the types of protection they each provide. From the cathodic protection provided by zinc to the barrier coating of aluminized type 2 to the environmentally resilient polymer laminate coating, which results from a strong chemical and mechanical bond developed during the lamination process. Of course, inherent within each of these coatings is its ability to perform in specific environments. Not all coatings are created equal. This table presents the expected service life for each of these coatings based upon the environments in which the products are installed, including pH and resistivity ranges, and the maximum allowable FHWA abrasion level. During our second session, we covered the structural design methodologies used to develop fill height tables for each standard diameter gauge and profile of corrugated steel pipe and pipe arch, using both the AISI methodology and using AASHTO load resistance factor design or LRFD calculations. Now, while there are seemingly countless options out there, the standard mechanical properties of the product allow for straightforward design calculations, resulting in consistent fill height tables regardless of the methodology utilized. Adjusting the various factors will have some effect on the tables. In most cases, that effect will be realized on the maximum allowable cover. However, the resulting maximums will nearly always exceed the maximum heights for competing products. This again is calculated by evaluating the ring compression of the pipe, also known as the thrust, and by a pipe's ability to withstand bending failure of the pipe wall. Thrust is calculated by combining 2 factors, dead load and live load, then multiplying that combined load by the diameter and dividing by 2. Simple and straightforward. The soil structure interaction between the pipe and the backfill is different for flexible pipe and rigid pipe. For flexible pipe, as the system is compacted and consolidates, the pipe will deflect along with the soil, shedding some of the load. While for rigid pipe, due to the increased vertical arching factor, this will attract the load. The ratio of the interaction is illustrated on this slide here. For a given load and condition, a rigid pipe will likely have to be designed to carry 3 times the load of CSP. Now, why is this important to have bending strength if the pipe is just going to be sitting in the ground covered by dirt? Well, of course, you have to move this thing around, right? And it's this resistance to flexure that is crucial when handling a pipe in the yard or on the job site. It also comes in handy during the actual backfilling process, most sensitively on larger structures. The structure must have enough strength to resist distortion and racking. This slide boils the structural design procedure down into 7 easy-to-follow steps. Once the properties of the pipe are determined, i.e. the gauge profile and diameter, along with the loads and the compressive stress or the thrust acting on the pipe wall, the maximum allowable stress can be checked, the flexibility factor can be checked, and if applicable, the seam strength for riveted pipe or the corner bearing pressure for pipe arch can also be checked. As we said before the pipe is completely backfilled and properly supported by the soil envelope, the pipe must have adequate bending strength to resist the shape distortion during installation and handling. As fill is placed against the pipe, the soil exerts active lateral pressure on the pipe wall. Additionally, forces are applied to the pipe through the backfill placement and compaction, so there's a certain minimum bending strength that is required to resist these forces. But once the backfill depth over the structure overcomes the active lateral pressure that the soil exerts, the structure becomes completely under ring compression. That depth of cover is typically span over 8, and that is often considered the minimum cover for normal live loads. The design of the backfill for these structures is extremely important. Corrugated steel pipe is dependent on quality, competent backfill due to it being a soil structure interaction system. The quality of the backfill is defined primarily by the soil stiffness. Non-plastic sands and gravels are preferred. While job site material can be suitable, organic materials are not recommended, and soils with some plasticity can be used in most cases. AASHTO requires backfill to be A1, A2, or A3 material per M145. This slide has a table correlating the unified soil classification system with AASHTO itself. Portion of the foundation in contact with the bottom of the structure is referred to as the bedding. Depending on the size and type of the structure, the bedding may either be flat or shaped. Good bedding foundations can be viewed as a cushion for the conduit and should be relatively yielding when compared with compacted material placed between the trench wall or the embankment and the pipe. In this manner, a soil arch can develop over the pipe, thus reducing the loads transmitted to the conduit. With flat bedding, which is typical for factory-made round pipe, the pipe is placed directly on the fine graded upper portion of the foundation. Soil must then be compacted under the haunches of the structure in the first stages of backfill. The upper 2 to 6 inch layer should be relatively loose material to allow the corrugations to seat in the bedding. The material in contact with the pipe should not contain gravel larger than 3 inches, frozen lumps, chunks, high plasticity clay, organic matter, or other deleterious material. Material under the haunches must be in firm contact with the entire bottom of the structure, and the haunches are more difficult to backfill and compact due to inadequate attention in some cases. Care must be taken to eliminate voids and soft spots. When handling multiple barrels of pipe, spacing must be adequate for proper backfill placement, haunching, and compaction. The minimum spacing depends on the size and shape of the structure as well as the type of backfill material used. When controlled low-strength material is used in these backfill situations, spacing is restricted to the spacing necessary to place the grout between the structures. Backfilling between and outside of the structures must proceed jointly to maintain a balanced load. Of course, multiple barrel structures are most commonly used in detention or retention system applications. And in our most recent webinar, we covered stormwater management practices and the benefits of going underground with corrugated steel pipe water quality systems. Detention and infiltration systems can maximize land value and in urban environments help with low impact development. These systems are highly customizable per the constraints of the sites. Bends, curves, double stacks, you dream it, it can be fabricated. We went into a little more detail in the design of these systems and the differentiation between detention and retention or infiltration type systems. discussing how by using the void ratio in the surrounding backfill, it allows for recharging of the underground water tables and prevents downstream flooding. We also discussed the variables that are used when needed to plug into any design software or calculations to determine the size of the system required. And then we went into some best practices for inspections of the system, both post-construction and routine, as well as other ways of best maintaining and operating the system. Now, all of these topics are available for review on the NCSPA website. This was just a quick review of the previous webinars that we went through. Each of these webinars can be watched, and the presentations can be downloaded for further review. So this leads us into today's topic area. To tell us more about the environmental benefits and sustainability of corrugated steel drainage products, our featured speaker with us today is Ray Wilcock, FCPA, FCMA. So no one else has to look that up. That stands for Fellow of the Chartered Professional Accountants and Fellow Certified Management Accountant. Ray is currently the Executive Director of the Corrugated Steel Pipe Institute. He holds a science diploma from Champlain College and a Bachelor of Commerce from Concordia University in Montreal. In 1985, Ray acquired his CMA and in 2004 was conferred to the title of FCMA. Upon graduation, he started with Dominion Bridge, a company who built many of the major bridge crossings around Canada. Over the past 4 decades, he has held a number of senior executive positions in several corporations in the infrastructure industry. Ray, thanks for joining us today. I'll now hand the presentation over to you.
Thank you, Mike, and welcome everyone. The word sustainability has many, many meanings. And if you look it up in the dictionary, you will find that. The one that I like to focus on focuses on meeting the needs of the present without compromising the ability of future generations to meet their needs. I'm sure many of you have children, grandchildren, and I'm sure you'd like them to experience clean air, clean water, the opportunity to enjoy our earth as we have. So this is what my focus will be today on sustainability with regards to corrugated steel pipe and structural plate corrugated steel. There are 3 pillars with regards to sustainability. One is economic, which is basically profits. Second is environmental, which is our planet, and that is what I'm going to be focused on. And social, which is basically human people resources. The sustainability of the environment is very important to each and every one of us from just a social responsibility. We all want to live in a healthier environment. Obviously, safety is a given, but is very, very important. And for businesses today, you know, most businesses do budgets and they do forecasting and they look at economics and profits and so forth. But I find that in the last, say, 2 or 3, 4 years, that more and more businesses are including in their planning processes regards with their impact on the environment and looking at it as to how they can improve going forward. It's very important that we be proactive in this area, eliminate issues that exist today and those that will, you know, incur in the future. One of the things that we can do within our businesses and is encourage a culture of awareness for all our employees or whatever to take this, you know, very, very serious as we move forward. And we need to guide our suppliers to harmonize. So those people that we're dealing with and supplying goods to us, you know, we need to make sure that they're harmonized with where we're going forward into the future. The first step in sustainability is giving yourself a snapshot as to where we are today. Like how are we doing with regards to what is our carbon footprint with regards to the products that we're producing? The second stage is planning where we need to get to. You've all heard of the Paris Climate Accord, which states that by 2050, you know, basically the entire world is supposed to be carbon neutral. So that is the goal. It's 30 years out. However, to get to those 30 years, we're going to need to plan each and every year to take that next step with regards to reducing our carbon footprint. So what I'm going to talk to you over in the next 20-25 minutes is the environmental product declaration, the impact of corrugated steel products. Meaning, if you look at the pictures here, Mike showed you the stormwater detention system up on the left-hand side, top. Then on the right-hand side, you have a storm sewer that goes into the storm sewer market. And down below, you have structural plate corrugated steel. Those are going to be 2 underpasses. Those are basically on a highway that leads to Banff, Alberta in Calgary, near Calgary. Okay. When you're looking at the environmental impact of a particular product, you have to look at it from what we call cradle to gate, and then plus end of life of recycling. And it's reviewed by a third party. Obviously, if someone like myself were to review our own industry, I'm biased. I work in the industry and I'm going to have biased opinions and views and so forth. So it must be done by a third party. And we're talking about engineers, scientists, biologists, etc., who work for these different companies in North America who perform this type of work. So again, as I mentioned, it's a snapshot in time as to what impact one's product has on the environment. For us, we looked at a declared unit of 1 metric ton. Which is about 2,200 imperial pounds, so to speak. But we're using 1 metric ton. And it's done in accordance with the ISO standards 14025, 14040, 14044, and 21930. And I'm not going to go through those, but that is the standards that guide the third party to looking at products and coming up with their environmental impact. Just a few facts about the steel industry before I go on. The raw materials of steel are made up of iron ore. It's basically about 56%, and that comes from about 5% of the world's crust. We also have metallurgical coal, 28%, and then recycled steel, 16%. The steel producers around the globe produce basically around 1.8 billion tons annually. On an annual basis. There are 2 ways to produce this. One is called BOF, or basic oxygen furnace. That's about 70% of the steel production in the world. The other one is EAF, electric arc furnace, which is about 30%. And its main ingredients is recycled material. And with regards to corrugated steel pipe, it mainly comes from the EAF, electric arc furnace. So most of the corrugated steel pipe that is being made today and going into the ground is recycled material. And it can come from anywhere, from cars, from refrigerators, anything to do with steel that can be recycled. It's very important to remember that steel is the most recycled material on the planet, and it maintains its integral core. It does not lose any of its inherent strength. So for instance, if you were to melt plastic, you're going to lose its KPA or consistency strength. For instance, you would never put a recycled plastic material into a storm sewer or a sanitary sewer. You could possibly have issues just because it's not the same inherent strength as, say, pure virgin resin. Whereas with steel, it doesn't matter. Recycled material has the same inherent strength as, making it from iron ore. We also have a 96% efficiency rate from raw material to finished product. And slag is the one main byproduct in steel making. Slag is used in cement making and a number of other areas. So, if you were to go back in time, I don't know, 20, 25 years ago, say, give or take, when I started in the corrugated steel industry, I started around 1988. Where I live in Canada is Kitchener, Ontario. And Hamilton, Ontario is about, 40 miles or so from me. If you were to drive back, 30 years ago, 35 years ago, this is what you would have seen over the city of Hamilton. Basically just a smog that was created and sitting over the city from all of these smokestacks and so forth. Hamilton is a big steel city, just as, say, Pittsburgh is in the United States. So that's what you would have seen about, like I say, 25, 30 years ago. We've come a long way. We still have a long way to go, but that's what it was. So when this third party started looking at, how we were doing and what our environmental product declaration was, the first thing they have to do is create what is called PCR, or product category rules. So every product that's out there, they will have a PCR. Then what they do is they take the life cycle inventory, or the data, which is the inputs and the outputs of making corrugated steel pipe. They run it through what is called a life cycle assessment. So for example, how long it lasts, how it's recycled, and then they produce the impact, which is called an EPD, or an environmental product declaration. If you look at this chart here, start on the left-hand side at the top, you'll see resource allocation. So again, that could come from scrap or pure iron ore. So you have resource acquisition, you move into the production stage, then you go to the distribution stage, you have the usage by the owners and so forth, and then the end of life. And again, is it recycled, is it landfilled, et cetera, et cetera. It's all taken into consideration to produce your EPD. As I mentioned previously, corrugated steel pipe, most of it is made from scrap. So it's raw material extraction and processing. We use energy and transportation with regards to taking that scrap, moving it over to the mill, and then producing coils of steel. There's another picture just of a scrap yard. They're going to pick up all of those different cars and all those different pieces of steel, and then they're going to transport it to the mill. The mill that we partner with here in Canada is one of the largest steel making facilities in Canada. It is Dofasco, or it's owned by ArcelorMittal. You may have heard that name. They are the largest steel making facility in the entire world. They have the most plants worldwide, I believe up to 65 and so forth. And Dofasco, or ArcelorMittal, is one of the largest steelmaking producers in Canada. So the scrap material goes to the steel mill. It is run through, goes through that particular process. Whoosh, out comes a coil of steel. It can be, as Mike said before, it can be galvanized, it could be aluminized, an aluminum bath. It could go through to polymer laminated to that particular process, depending upon what is required. But in the end, once that steel runs through the steel making process within the plant, a coil is made, and then it is inventoried. These coils will run, let me just go back here, sorry. These coils will run anywhere from, say, 5 to 10 ton coils. That's how big they would be. Next slide is just to let you know that the next webinar for the NCSPA series will be 2 weeks from today, July 23rd at 2 p.m. Eastern Standard Time, and it will be on quality and certification of corrugated steel. And Mike will talk a little bit about that at the end when I'm finished. So again, that material is inventoried in the yard at the steel mill. It is then put on a transport truck or railway, depending upon how it's going to be shipped to one of our manufacturers, the people who actually make the pipe. So it's shipped to a manufacturer. The manufacturer will load it, probably store it in the plant, just to keep it, out of the necessary, particularly up here in Canada. We have a very harsh winters and so forth, so it will be stored inside. When they're ready to make a product, and an order comes in, or they want to make it for inventory, it's on the picture on the left, you can see it will be hoisted up onto a particular machine. We call it a Hellcore machine or a CSP machine or whatever you want to call it. It will be run through a series of profile dies, and this will produce a certain corrugation depth and width or pitch. And that corrugation will depend upon the size of the diameter. So you can have smaller corrugations up to larger corrugations as you get bigger. That picture on the right, that is that arm that you can see going through that particular pipe will determine the diameter of the pipe. Smallest diameter that we make up here in Canada, and probably the same in the United States, is 100 millimeter or 4 inches, up to 3,600 millimeter diameter or 144 inches in diameter. We use, obviously, energy. That pipe can be made, it's normally made to standard lengths. Nevertheless, it can be made as long as you want it, and as long as you can safely transport it to a customer, and long, you know, as you can put it on a flatbed truck and ship it and so forth. We keep up here in Canada 6 meter and 8 meter standard lengths. Okay. So the inputs that we provided, all of the inputs from the steel making facilities came through from DeFasco and also the World Steel Organization through AISI in the United States. So all of that information was taken, and then our members had to come up with what do they do once they get that coil of steel from the mill. What are the inputs and outputs that they have to go through? Well, they use coils, they use electricity power, they use natural gas within their plants, they use propane, they use diesel, they use lubricants. As far as outputs go, they would use timber, for instance, for pallets or skids. There is steel scrap that will come about when you're making different products, and there will be packaging and so forth. So those would be the inputs and basically the outputs that come about with regards to a corrugated steel or a structural plate corrugated steel plant. And then it's transported to a customer. And again, it can be transported via rail, truck, as you see on the right-hand side, or a flatbed truck. It depends, a number of different ways, but those are probably the two main modes of transportation to get it to the customer. Now, if you were to, once all that is done, and the third party goes through, they produce a 12 or 13-page report called an environmental product declaration. If you were to look at ours on our website, and I know Mike is going to show you that a little later, you would find a page on here it'll call results. And if you look at this, unless you're a math whiz, it's not easy to look at and say, well, what the heck does that mean? Particularly when you look at numbers like 5.06 times 10 to the minus 8, or 1.79 times 10 to the minus 13. I know all of you out there could probably do these calculations and figure out, but it's going to take you time. You're not going to be able to do this very, very quickly. Now, I've done it for you, and I'm going to show you what this means. But if you look on the left-hand side, you'll see impact category. You'll see all of the different things that we impact, like global warming potential, the ozone depletion, acidification, eutrophication, and so forth. The next one is the units. How is it measured? So metric tons, the first one is metric tons of carbon dioxide, CO2. The next one is CFCs or sulfur dioxide and so forth. So again, that's the units that they measure it in. And then the next one is the product stage, the next three columns. So you have steel production, you have transport to the manufacturer, then you have manufacturing, and then you have end of life, reuse, recover, recycling potential, and so forth. And I just want to point out, and I will go through these numbers in a little more detail, but if you look at just the global warming potential on that first line, you'll see steel production A1 of 2.21 carbon, kilograms of, or metric tons of carbon. Transport to the manufacturer is only 0.02. The manufacturers of corrugated steel from those coils are 0.03. You can see that the largest impact on a corrugated steel or structural plate is in the steel production itself, okay? Just to show you. It's a huge difference. So what we did was I took those numbers and I decided, well, I'm going to show you what are the results of producing 1 metric ton of steel. What does that mean? Well, from a global warming potential, we would produce 1.5 tons of CO2, carbon. That's equivalent to driving your car about 32% of the year, when in Canada, driving 5,907 kilometers, or in the United States, 3,570 miles. That's the average driving that somebody would do, just to show you. Or to heat or to have electricity in your house about a quarter of the year, 26%. So that's what you would use with regards to 1.5 tons of carbon. Or you would use 61 propane cylinders for your home barbecue. Just to give you an idea of what does 1.5 tons of carbon actually mean, okay? So I have been asked many a times by different consultants up here in Canada, municipalities, even some of our provinces, what is the environmental impact of your products on this particular project? So when they're looking at the selection of products going forward, they're going to be looking obviously at cost, they're going to be looking at durability, how long it lasts, but they're also going to be looking at what is the environmental impact of your product. So I'm going to show you an example that I did for a consultant recently. It was a storm sewer. It was spiral rib pipe. You can see those are pictures of spiral rib where you have a Manning's flow of 0.012 on the inside, and it's ribbed on the outside. It is 450 millimeter diameter, or 18 inches diameter. The thickness was 2.0 millimeters, or I put 12 gauge, but it's actually 14 gauge. I just typed in the wrong one. So it's 14 gauge material. So with 1 metric ton, you would produce 37 meters in length, or basically 6 pieces of pipe. So for that 1 metric ton, okay? Just to give you an idea and try to break it down for you as to what the impact is. So the greenhouse gas emissions of 1 meter length of that particular pipe, CSP would produce 40 kilos of carbon, or 88 pounds of carbon. That would be made up of steel making, which is 96%, transportation 2%, and from our manufacturers of corrugated steel or structural plate, 2%. That's like driving your car. So for 1 meter of that pipe, which is what, 39 inches, just over a yard, you would drive 158 kilometers, or 98 miles. That's using 1.6 propane tanks for your barbecue. Give you an idea. Now, if you extrapolate that out by diameter, you'll see on the y-axis, you'll see kilograms of carbon, CO2, so from 0 up to 350 kilos. On the bottom, you'll see diameter from 450, which is 18 inches, up to 2,400 millimeter diameter, which is 96 inches. You'll see that obviously the larger the diameter, the more kilos that you're going to produce by carbon. So that is the scale that we have, just to show you what it's like. Okay. Another area that is important is obviously acid rain, or what they call acidification potential results. If you look at the pictures on the left and the right and the bottom, everybody has seen that near rivers or lakes or whatever. That's the fallout from acid rain from the emissions that we have put up into the air. It's measured by sulfur dioxide. Again, per 1 meter of 450 millimeter diameter, CSP would produce about 29% of a kilo, or about 64% of 1 pound, just to give you an idea. So when a consultant was looking at this, they were able to take those numbers, and then let's say, they're basically, not doing 1 meter, say it's about 300 or 400 meters for that particular project. They're able to calculate this out and can, come up with basically what is the true impact of our environmental imprint. And then they can compare that to other materials like concrete, like high density polyethylene, like PVC, and so forth. Another area is eutrophication, which is pollution of water and soil. Again, look at the picture on the bottom left or the bottom right, You can see that dead fish there. Everybody has seen that green algae that forms in the water. That picture on the top right is a picture that you can see a shadow there. That's actually my shadow. I'm taking that picture. That is a polymer-coated structural plate. And that water was just awful. If I had fallen in there, I would come out not looking too well. I tested that water, and the chlorides in there are just horrendous. So that material, thank goodness they put polymer in there. Nevertheless, for 1 meter of 450 millimeter diameter of eutrophication, we would produce 0.012 of a kilo and 0.026 of a pound. Another area that they look at is smog creation. All of you have seen this in some cities around the world. I was in Delhi back in 2009. You can hardly breathe when you come out of your hotel. It is very difficult to breathe, and I'm sure in other parts of the world they're the same. That is what we're doing. We're creating smog, and it sits there on the cities, and it's not dissipating and so forth. So it's measured by ozone depletion. For CSP, for that 1 meter, we produce about 4.24 of kgs of smog, or about 9.35 pounds of smog. And then the last thing I wanted to mention with regards to the results are depletion of abiotic resources or fossil fuels. We measure this by energy consumption, megajoules per meter of that 450 millimeter diameter. We produce about, for CSP, 516 megajoules. So that is our snapshot in time. And consultants now are able to compare us, corrugated steel, to say concrete, to see, who has the smaller carbon footprint today. And in fact, we're doing a study up here in Canada with a third party that's actually looking at it. They're looking at our environmental product declaration, and they're looking at concretes, and they're going to determine who has the smaller carbon footprint today. It doesn't mean it's the same tomorrow, but today we want to find out from a third party how we stand up. So going forward, these are some of the plans that we have to improve and lower our carbon footprint. Steel makes up about 7 to 9% of the CO2 that is emitted today in the entire planet, just to let you know. It's a fact. We are looking to reduce our carbon emissions from primary steel making. The gases from steel making, once cleaned, are now used internally to produce steam and electricity. Dofasco, who was one of our partners up here, spends about $200 million per year on research and development. Their goal is stated zero carbon iron ore reduction technology. So by the year 2050, they will be carbon neutral. They have 3 technological pillars. One is electricity, one is hydrogen, and one is carbon. Storing it, utilizing it, or reducing it. But however, regardless of what they do, public policy support is needed for an accelerated transition. And I'll explain that on my last slide that's coming up in a few minutes. Plans going forward for transportation, we're always looking for alternative methods of transportation. For instance, like electric vehicles going forward. Our manufacturing plants, many of our members are now, as I mentioned, including this in their planning profile each year. They're looking at retrofitting their plants and making them carbon neutral going forward. They're looking at electric vehicles, electric forklift trucks versus, say, propane or gas-fired. They're looking at capturing, recycling, elimination of all natural gas, oils, lubricants, and propane with alternative technology. Anything from, you name it, solar to wind to what have you. So those are some of the plans that people are talking about at this stage of the game here in Canada. I believe this is my last slide. I just wanted to mention to you that it's very important that legislation exists to move this forward. If we do not have legislation, and I'm talking about across the planet, you all know that borders don't control the skies. And if we pollute in one area, and even though somebody else is clean as a whistle in another area, we're all going to be impacted by the polluter. So that is why the Paris Accord was brought together, and I believe only 2 or 3 countries in the entire world have opted out of that. Nevertheless, hopefully they will be forced one day to move forward and make this become a reality. In the United States, you have what is called a Buy Clean California Act. I believe by 2021 or whatever, you will be using EPDs. They will be using EPDs to determine if suppliers fall within the stated global warming potential. So my reading of that is that they will have a bench line for each particular product material. And if your product doesn't meet those bench lines, you may be excluded from, submitting bids and working on future, state projects and so forth. And that's starting to happen here in Canada. In Alberta, for instance, one of our major provinces, they have that every bid that goes in, there has to be almost an environmental submission to ensure that you're complying with their environmental framework going forward. We also have our Canadian government. They have what is called a low carbon assets through life cycle analysis. They have a group that they put together. There's no doubt that COVID-19 and this current pandemic we're in has more or less sidestepped and put climate change on the back burner a little. Nevertheless, it is still ongoing, and we expect it to, ramp up even further as, we move forward into, say, 2021 and beyond. And the last one is we do have one of our cities, the city of Calgary in Alberta. They've moved to what is called Envision, where they're now looking at every single thing that they do, the things that they procure, the carbon that they produce, and their whole idea is to get a handle on it and then again move towards and plan towards carbon neutrality. So I appreciate those who have tuned in today. Thank you for listening. And if you have any questions, I'd be feel free to ask, and I'd be free to answer. And turn it over back to Mike at this stage of the game. Thank you very much.
Thank you, Ray. Very interesting and very compelling stuff. Really, really appreciate you joining us here this afternoon. So moving forward, gang, as a recap and to summarize and sum things up, where can you get more information on this? Of course, as we've highlighted in the past, the NCSPA website is full of a wealth of information on a number of things. Also wanted to highlight, as Ray had mentioned before, the CSPI website. CSPI does have their EPD posted here. CSPI.ca is the URL. You can surf that. They have a tech bulletin that's also available for improving our environmental footprint. Of course, the NCSPA site, we are continuing to develop tools around this particular topic. The webinar, of course, that we're conducting today will be a cornerstone of that. But we will also be following suit with our friends up in Canada developing EPDs and the like. For more information and more resources, of course, you have the Corrugated Steel Pipe Design Manual available for download on the NCSPA website. There's also the NCSPA Installation Manual for basic considerations when installing either corrugated steel pipe or structural plate buried bridges. You can, of course, find a project in a number of application areas from detention and retention, storm sewer, structural plate rehabilitation, and the like on our website under Find a Project. You can filter those by project application or by product coding. Just highlighting some of these examples are some projects of the year winners recently and from the past. This particular project, as we talked about last week, just highlights the ability and the customizable ability to design these types of systems. The large storage capacity that can be developed when using these types of systems. Long lengths, as Ray alluded to, if you can fit it on a truck, we can manufacture it. This is how those look. So, gang, with that, we're going to wrap up this afternoon. Thank you all again for joining. You can follow us on our various social media channels. Once again, we will be conducting another webinar in 2 weeks from now. That webinar will go into more detail on quality and manufacturing processes and various certification programs that exist currently. So with that, we'll open it up for any discussion and any questions that folks may have here for the rest of the time. Thank you again for joining us this afternoon. As I'm not seeing anything in the chat room. Ray, we have a few minutes. Is there anything that you felt like you'd want to delve a little more into or reinforce?
I guess the biggest thing is, as I mentioned, we are doing a comparison of concrete pipe right now. And again, it's not to make us better or look better or whatever, because it has to do with where do we stand right now on that scale of moving forward. Because it has to be a sliding scale downwards. It's the only way we're ever going to get there if we all agree that, we want a better future, or at least the same future for our children and our grandchildren. I have 8 grandchildren, and I know my eldest, Sophie, asked me a question, I think this past summer. She said, Grumpy, what are you guys doing with regards to the environment, and climate change? So you have young people who are, this is a serious, serious issue. And, people my age, sometimes we may scoff at this or look the other way. But the fact is, it's our generation that, and our forefathers who've done a lot to, where the situation we're in. So again, I'm hoping that, after COVID or whatever, we'll start to see the entire world come together with regards to climate change and treat it like we're doing COVID, which obviously is very serious. So that's my hope. Joel Haum asked, do you have any preliminary information for how similar concrete and plastic pipe products compare? Joel, yes, we do. But again, if I tell you, it's because I'm biased, because I've done the comparisons myself. We have about we're about say 50% of concrete's carbon footprint today, snapshot. But it's hard for me to say that and politically and go out there and market it or whatever, because it has to be verified by that third party, and that's what we're doing right now. But from my standpoint, I can say it that we have we're 50% of concrete, and we have a much smaller carbon footprint than high density polyethylene. I can't find an environmental product declaration for HDPE. I can't find it out there. It's not on anybody's website, or it's not in Sustainable Minds or whatnot. But I have looked at past studies that were done at different universities, and I've done the comparisons, and we have the smallest carbon footprint out there of any pipe that exists. I may be proven wrong. Nevertheless, I'll wait till a third-party report comes out, which should be out in another month and a half.
Very good. Any other questions out there, folks?
One of the things, Mike, that municipalities have asked, I've been to a number of sessions with regards to different municipalities in Canada. They're all grappling with, where do you start? Where do you go from here? A lot of municipalities have come out with statements that we have an environmental crisis. Well, it's easy for a politician to state that. It's another thing to do something about it. There are no action, there are no plans, except we have a crisis. Well, a crisis demands at least something, some kind of a plan to go forward. And it's interesting to see because it sounds good, right? When somebody states that, people look at it and go, oh, my city is taking this very seriously. But when you look at what they've done, it's really, they mentioned the statement, but they haven't done much about it. So my hope is that, the federal government, particularly up here in Canada, will impose some legislation going forward and start mandating this and making it happen. Because all we're going to get out of this when it's all said and done is a future for our children and grandchildren.
Well said. So Bruce asked, do you see sustainability becoming a more important factor in material selection going forward?
In Canada, absolutely. I think in California, just based on reading that environmental act that they have the Clean California Act, I do. I can't speak for, you've got 50 states. I can't speak for any of those others. But for Canada, we have 10 provinces and basically 3 territories up here. And in the sessions that I have attended with regards to, I live in Ontario, which is the largest province in Canada. Ontario, Alberta, British Columbia, Saskatchewan, and Quebec. I see a lot of push towards that. And I think it's a matter of time, but I do believe that it's going to happen very soon, where our manufacturers will have to meet certain criteria in order to, produce and, bid on specific public tenders.
Yeah, no, I don't have much to add there, Ray. I think you're exactly right. California is at the forefront of what's going on down here in the States, and we'll remains to be seen what other states will follow suit in regards to their path forward. So
yeah, there's always one, like up here we have British Columbia, which has been leading the charge. And there was always that label that people put on them that they're a bunch of greenies or whatever. But the fact is, it always takes one area that needs to push the rest and wake up, so to speak. And for us, it has been British Columbia. There's another question here, Mike. Are there any promising technologies on the horizon to lower the overall footprint of steel production? Well, within the steel mills themselves, yes. As I mentioned, there is a report, and if anybody's ever interested in it, you can download it right from the ArcelorMittal site, or you could send me a note and I could send it to you. It's about a 100-page document, and it highlights the areas where they are working on towards lowering their carbon footprint. They're working on all kinds of different areas. It's quite the document, very detailed. With regards to transportation, as I mentioned, electrification, railways, etc. But within our own manufacturers, as I mentioned, they have plans in place to look at redoing their plants in the future. They're going to need help because these are expensive propositions. They're going to probably need some public support help here or whatever, but they're going to look at redoing their plants, hopefully in the future, electrification of vehicles, and again, looking at anything that they use that produces carbon. What can they do better? Can they do it differently, or can they capture that carbon and turn it into something else, some other energy or whatnot? So I think there is. I really do. And if you look at the steel industry from 25 years ago, they have come a long way. We don't see the smog like we used to over the city of Hamilton. Yeah, they're still, spouting off carbon into the environment, but nothing like it was 25 years ago. So, my hope is that 25 years from now, it'll be so clear and clean that you won't see anything, being emitted. But that report is available on the ArcelorMittal website. So again, I can point you in the right direction. My email address is rjwilcock@cspi.ca, so you can send me a message anytime and I can point you in the right direction. Or send it to Mike. Mike has, Mike, we always converse, so, you could send it to Mike and I can send it to him.
Thanks for the great information, Ray. Yeah, I mean, I
Very
agree.
welcome.
And I think as the steel production moves more from BOF and large into ALF, I mean, or EAF, it's going to really make a big difference too. I mean, the slide that you showed with 70%, 30%, as that ratio climbs, you'll see even greater reductions.
Absolutely. We have a lot of steel scrap out there, and you know, why do something new when you can redo it? So it's great. Yeah, absolutely.
Any other questions, folks, before we wrap up? All right. Well, thanks again for your time this afternoon. We will make this webinar available on the NCSPA website in the next few days for future review. Again, the PowerPoint slides will also be available to download and view. Thanks again for your time and attention again this afternoon. And Ray, thank you again for all the great information you provided.
Very
Take
welcome.
care, everyone. Stay safe.
Thank you for having me.